right. Hi, everybody. Thank you so much for attending the talk. And I'm so pleased to see how many countries everybody is coming from. That's really nice. One advantage of this internet technology. All right. So my talk today is based on a paper that I wrote with my co-author, Dr. Dan Weary, where we explore the idea of a good life for laboratory rodents. So for my talk today, it's going to be about an hour long. I'm going to start with a brief introduction, then explain what I mean by a good life. We're going to then talk about the physical environment and interaction with humans and how those two can contribute to a good life. And then we're going to finish with the conclusion. So to begin, I think most people who use animals in research, or when we talk about research, everybody pretty much agrees that we should spare animals from any unnecessary harm. What that means in practice is that the animals shouldn't go hungry, they shouldn't be thirsty, they should be free of communicable diseases, and they should be provided pain relief when that is appropriate. There's also more and more emphasis on giving animals some kind of environmental enrichment, but the reality is that this is only given in instances where this enrichment is perceived to be both practical and not to interfere with study aims. So sometimes there is no research saying that it isn't, but because there are fears around that, it is not given. Is this an acceptable standard of care? Dan and I, Dr. Weir and I argue that it is not, that it is now time to work towards a higher standard of care for lab animals, and that providing these animals with a good life isn't just a duty, but it should also be a prerequisite for their use. So instead of designing your research project and then kind of adding in some good things for the animals as you can, we should go the other way around, where you design your care of the animals and then you design your project around that. So the aims and the scope of my talk today, the main aim is to illustrate with a lot of examples how we can provide a good life for laboratory rats and mice specifically. And I want to say at the outset that I recognize that many research procedures are clearly incompatible with a good life. So for example, when you're causing your animals long-term harm, these can absolutely preclude the ability for these animals to have a good life. But the aim today is to describe what I consider to be the minimum day-to-day living conditions that should be met at the outset when using rodents in research. So what is a good life? Let's kind of set the common ground so we all know what I'm talking about. I think many of you are familiar with a definition of animal welfare. It's said to be kind of lying at the intersection of three spheres, which are affective state, so how the animal is feeling, biological functioning, how the animal is health-wise, biologically, and natural behaviors, so the ability to perform motivated behaviors. I think most agree that having good welfare is somewhere in the balance of these three spheres. But when I talk about a good life, I am talking beyond these three domains of animal welfare. And there's different researchers, philosophers who have argued different definitions of what a good life is. So I'm going to overview a few that I think are quite good. The first one is philosopher Martha Nussbaum, where she says that every individual has dignity, that every individual must be allowed to flourish as the kind of thing that it is. So if you're a mouse, you should be allowed to be a mouse and live as a mouse. If you're a dog, you should be allowed to live as a dog. Animals must be allowed to utilize all their innate abilities, and in general, they should be allowed to experience a rich plurality of life activities. So be able to engage in an animal's full potential using a lot of abilities. In general, when people talk about a good life, there is a recognition that what's really important and central to a good life is engaging with the environment, learning, and overcoming challenges. So for example, an animal welfare scientist, Françoise Wemmelsfelder, says that the quality of life depends on different opportunities that animals have to pursue their own interests. Ethicists Purves and Dellin say that a meaningful life stems from intentional actions or own agency, so having control in one's life. Spinka, who is also an animal welfare scientist, proposes that there are 4 types of agency, so it's kind of a scale that builds. The first one, the lowest type of agency that you can have, is this passive reactive agency, where you're basically just doing a direct reaction to an external stimulus. So for example, if you're a mouse, somebody reaches into the cage to grab you and you retreat to hide. That is this passive reactive agency. That is kind of the main type that we're currently providing animals. The next one up on the scale is action-driven agency, where this is you're using active behavior to achieve an outcome. So something like building a shelter. So for a mouse, building a nest would be an example of this. You are choosing to perform behavior to achieve this nice nest. The next level up is competence building agency, and this involves active skill building, learning things for future use. So here, for example, is exploration, where you're going to actively go explore, learn about your environment that you can later use to find resources. It is also playing, for example, where animals will engage in play in order to build some skills. Now, the final tier is this aspirational agency, which is the pursuit of planned and reflected goals. So this is kind of reflecting on what you've learned, how you can improve in the future, etc. Now, Spinka argues and has given some evidence that the second and third types of agencies, action-driven and competence building, are associated with positive affective states, and they also contribute to the expression of full species-specific potential. So really, we do need to try to achieve at least these two types of agencies with animals. So in summary, when I'm going to be talking about a good life, what I mean is a life that requires where animals are able to express a rich behavioral repertoire, they're able to use their abilities, they can fulfill their potential through active engagement with their environment. So here's a quick roadmap to a good life that we outline this in the paper. I'm going to break down this talk into two basic sections, which are the physical environment and interactions with humans, as I've said at the beginning. And what I'm going to do in each section is walk you through some of the more immediate basic things that you can start doing tomorrow, through some of the intermediate steps, and eventually what the goal is to have a good life. So let's start with the physical environment. The reason I'm interested in the physical environment for these lab animals is that it's the most pervasive element of their lives. They're basically spending their entire life within the confines of their cage. And so the shape, the size, the features of this cage become, they set the limits of the animal's experiences in life. We know that cage design, so basically your shoebox standard cage that everybody uses around the world, has changed very little since the 1900s. Back in the day, it was basically built just for ease of handling and cleaning, not based on any scientific research, and we continue to use it today. And so really, we need to be looking at some science-based evidence for rodent behavioral needs and welfare in order to update the standards that we're still using today. So what can you do in the physical environment immediately? Talking about a standard cage, so we're still within this shoebox cage. There are basically two main features to that. There's bedding and there's a shelter. The function of bedding is to absorb moisture, and it also has to be comfortable for the animals to live on. They're in contact with it basically their entire life. And the function of a shelter is to protect the animals from light, from cold, and from perceived threats. In North America especially, but in Europe as well, corncob is very popular. The reason for it, and some good feature of it, is that it is the most absorbent material, and it's also associated with the lowest ammonia levels, which is good because ammonia can be irritating for the animals. However, the list of cons is also long. So for animals that are living on corncob bedding, it's been shown that this bedding is associated with acetic acid and sulfur dioxide, which are respiratory irritants. Mice who sleep and live on corncob bedding, rats that are housed on corncob bedding have shown that they have disturbed sleep. In mice that live on corncob bedding have estrogen disruption, which leads to more aggression. And more importantly, corncob is really disliked by rodents, probably because it's a very hard surface to be on. So if you look at preference tests, mice and rats both always avoid corncob bedding. And in one study, they even showed that rats were housed on aspen chip, was just sleeping straight on the bedding, whereas rats that were housed on corncob bedding would push the bedding away and decide to sleep just on the cage floor. So if we look at research into other types of bedding than corncob, if we look at preferences of the animals, both rats and mice seem to prefer filter paper over wood chip over sawdust. If we look at some health outcomes, so in terms of lung pathology and sneezing associated with different kinds of beddings, research has shown that loose pulp, which is a type of paper bedding, is better than wood chip. So what we have here is kind of, if you look at this filter paper, loose pulp, they're both paper-based beddings. And so what we find is these paper-based beddings seem to be associated with fewest deleterious health effects, and also they're preferred by rodents. So there's many different types of paper beddings. You have Carefresh, you have Ultra Dry. The con of these paper-based bedding is it has a lower absorbency than corncob, for example. And I did put an asterisk here because some newest research is showing that some of the new cellulose products actually are quite very absorbent, perhaps even more so than corncob. But assuming that they're only moderately absorbent, what can we do to kind of combat that? One of the solutions is to increase cage changing frequency. I don't recommend that. It is costly, but also it is disruptive to the animals. And another solution would be to provide deeper bedding. Here's an example of a study that looked at the effects of housing mice on deeper bedding. So they had 3 treatments. So one had 0.5 liters bedding, one had 1.5, and the next one had 6 liters. What they found is that the deepest bedding was associated with the lowest ammonia levels, lower corticosterone levels, which means lower stress, lower food intake, and higher body temperature. And it was also strongly preferred by mice. So even though you're spending more money on putting more bedding into the cage, the fact that the animals eat less and have higher body temperature, you might recuperate some of that money there. So the evidence from that part of the literature review suggests that we really should be housing rodents on deep paper-based bedding in order to improve their welfare. Now I'm going to move on to shelters, which, as you remember, is kind of the only other feature in a standard cage. When we talk about rats, kind of just going back to their basic biology, where they came from, they do live underground. They are burrowing rodents. Their housing consists of a long tunnel that leads into a nest chamber, and that nest chamber is always lined with some nesting materials, so plant materials. If we look at in a laboratory, if we look at preference testing for rats, we know that they do prefer to have both a shelter and nesting material, but if they have to choose, they're going to choose just a shelter over just nesting material. And one study actually showed that rats who were given both the shelter and nesting material compared to rats who were only given a shelter had a reduced severity of over-grooming related self-injury. So those that were barbered were not actually getting as injured or barbering as much. Most of you, if anybody works in the lab, what you've seen as shelter, what we almost always give to rats are these open-ended tunnels. Unfortunately, research has shown that rats don't really like these. What they most prefer are shelters that only have one entrance and that are darker. So if we go back to the function of a shelter, it's supposed to protect the animals from light, from cold, and from threats. And really, if you look at this open-ended, opaque, darker boxes, they're really good at doing that. The one entrance means that they can guard the entrance and kind of feel safe in the back. It's also bigger, will fit several rats at once, which means they can cuddle, have better heat insulation. And if you look at those open-ended tunnels, they're not as good at doing that. The light comes in from both ends. Both rats can't actually fit in the tunnel, and it will often just kind of take turns and rotate through the tunnel. When we go back to the biology of mice, mice also like to nest within a protected area, so that can be inside some kind of a shelter or underground, and they will sometimes also build a nest above ground. In a laboratory, in terms of preference testing, same as rats, there's evidence that mice prefer to have both a structural hut and nesting material. But for them, if they have to choose, they will choose only nesting material over only a shelter. So that's the opposite from rats. So for nesting materials, which is the best shelter to give for mice, preference testing has shown that they much prefer to use tissue paper or paper towel over crinkle paper and over wood wool or wood shavings. However, if we look at nest quality, so how well the nest actually is able to keep its structure and keep insulation, research has shown that crinkle paper is better than tissue paper or compressed cotton. So if we kind of look at those two top ones, tissue paper and crinkle paper, what we can do is if we give animals both, we find is that the mice will build these beautiful 2-layered nests where they will line the inside of their nest with their preferred soft tissue paper and then use the crinkle paper as like structural outer layer. Okay, so moving on from shoebox cages, kind of still within shoebox cages, but moving on from really the basic things that we're already doing but could be doing better. What are the intermediate things we can start doing? Adding complexity. I think that's a no-brainer. We know enrichment is good for the animals. For rats, I wrote rats, but actually rats and mice both prefer structurally complex environments. And we know that in basically any research that compares a standard cage versus something that's more complex, the animals always do better in the more complex environment. They will have lower anxiety, lower depressive states, strong immune systems, lower susceptibility to different diseases such as cancer and neurodegenerative diseases. In a study looking at rat preferences for enrichment, we also know that they will prefer to have a variety of different objects versus having just one copy of an object or even 5 copies of a single object. So variety is key, so amount, but also variety is what we're looking for with rats. We can also add a wheel. Cages have to be taller to fit that, but we know that rats are highly motivated to run. When they're giving a wheel, in one study, they showed they would run up to 1 kilometer per day. They would also learn how to unlock a wheel to be able to use it. They will work in order to gain access to an area with a wheel. And they will also vocalize in this positive range, which is the 50 kilohertz range. It's associated with a positive emotional state. So they will do that both in anticipation of running and while they are running. So here I'm going to start walking you through different examples of what people have done within standard or basically standard shoebox cages. So in this example from Van der Harst in the Netherlands, they were able to increase the usable space inside a rat cage by 45%. Basically, they added a raised lid and they added a bunch of structures that the animals could rest on, could climb through. They included some gnawing sticks as well. And here on the left-hand side, they also had a litter pan. The rats were set to spontaneously start using it. And so when at cage changing, they were able to just change out the litter pan instead of disrupting the animals and changing the whole cage. When they looked at some welfare assessments, they found that rats were strongly motivated to access this enriched cage. And rats that were permanently living in this cage compared to rats who are living in the standard cage also had lower stress levels. Here's an example of something simple that can be done to increase complexity in a mouse cage, basically adding a cage divider. So what this is just it's actually commercially available cardboard insert that you can insert through the lid, and it divides half of the cage into what they call 3 burrows. What they found in a series of studies is that mice will often build their nest in one of those burrows. It's kind of a tighter enclosed space that they really like. They found that if aggression started in those cages, the mouse that was being pursued would often just retreat into one of the burrows, and that would effectively end the aggressive chase. They found that overall, mice who were given these cage separators had fewer aggressive events, they had fewer bite wounds, they also had better weight gain and lower anxiety. Here's another example of a mouse setup. So this was done at the University of British Columbia by a veterinarian who worked with us. What she did is she took a rat cage and stacked a little bit smaller mouse cage inside. She would then drill a hole in the bottom of the top mouse cage and fill the rat cage with deep bedding. So basically, you're kind of introducing this 2-layered cage that doesn't take too much more space than a standard cage. What she found is that mice would sleep in the bottom during the light phase because it was darker. And then they would use kind of the top layer during the dark phase to use their wheel and go about their active behaviors. If females were bred in these cages, they would give birth and keep their young in the bottom cage that was more secluded. And these mice would also create nice tunnel systems all the way down into the bottom of the bedding if there was a kind of structural tunnel buried inside. I'm going to talk about something that's not talked about very often, which is this idea of segregation of space. So when we talk about rodent cages, we pay a lot of attention to minimizing ammonia levels for health reasons that are very valid. But there's a lot less work that looks at rodents' motivation to avoid contact with the urine and feces, even when ammonia levels are acceptable. This becomes really relevant because with the advent of these new caging technologies, such as ventilated caging, it basically dries out the bedding and it allows for less frequent cage changing. And I want to show you why this becomes important. So in this study, in 2009, they were basically looking at how long can we get away with not changing the cage. So what can be the cage changing interval and with appropriate ammonia levels. So what they found is even at day 10, there was still 0 ppm ammonia. So basically they were arguing you can wait 2 weeks between changing the cages. But if you look at a photo of what the cages look like if you look at day 10, it is littered with feces. Basically, the contact bedding has become the feces. This may be an issue. We know throughout the animal kingdom, including humans, there are many examples of wanting to segregate where we sleep from where we go to the bathroom. So for example, with caterpillar larvae, they have this built-in mechanism where they will propel their feces or fecal pellets up to 40 body lengths away from them. With the leafcutter ants in Colombia, they live in burrows, but they will leave their burrow and deposit their waste in little piles outside of the burrow. And on top of that, they have dedicated waste worker ants who will further carry down the piles of feces even further away from the burrow entrances. Among birds, you have examples where the parent birds will carry the fecal sacs of their young outside of the nest. The burrowing species of birds, the puffin, will also have a designated latrine outside of the burrow, so they won't do it inside the burrow where they sleep. Multiple examples of separate nesting and sleeping sites in a variety of mammals and also a variety of rodents. But when we talk about rats and mice in a laboratory, they have no choice but to perform all their activities within a single small open space. So I did a study where we wanted to investigate where mice would choose to nest and eliminate in a standard cage versus a complex system that facilitated spatial segregation. So in this study, we used cages from animal care systems that are they're still very small, but they're shaped like a pie because it just goes around this circular cage rack, like pieces of pie. So in the standard cage, mice were given nesting material, food, and water. And in the complex system, we used 3 of these cages that were connected by tunnel. So that's how we chose the system, because it makes available these tunnels that you can buy that will connect 3 cages. In the study, we provided nesting material in each of the 3 cages, but food and water are only available in 1 cage. So what we found is that in both systems, so both the standard cage and the triple cage, urine and the nest were found in a separate location 98% of the time. So absolutely, mice are attempting to segregate where they sleep and where they eliminate. However, what this meant in the standard cage is that the urine and the nest were in separate corners of the cage, whereas in the complex system, the urine and the nest were always in separate cages. So they would place a much larger distance between where they slept and where they went to the bathroom when they had the opportunity. Also want to show you or draw your attention to the fact that the urine spot was almost always, so 98% of the time, it was by the water. That's where they chose to put the latrine. What we also found is that the standard cage seems to prevent the separation of feces. So in the standard cage, feces were uniformly distributed throughout the cage, whereas in the complex system, the feces were really almost uniquely found in the latrine cage where the water was and where the urine was. So what we think was happening is that within standard cages, as the mice go about and move around, there's this mixing of bedding. There's no way to keep that separated, as opposed to urine that kind of is more, it's wet and sticky, so that can stay in one spot. So when we're talking about improving welfare and giving a better life to these animals, I think we should use cage designs that can promote the segregation of space. We know from research that mice and rats both seem to prefer to eliminate near their food and water. So what we can do, for example, in a standard cage, you can add a litter pan that you can bed with something that is very absorbent, like corn cob bedding. You put that near the food and water, and then the rest of the cage can be bedded with something that is comfortable to sleep on. A better design would be to use, let's say, a double cage system or triple cage system, where one cage, the one that has food and water, can be bedded with something that is maybe not as comfortable, but very absorbent. And the other cage can be bedded with something that is comfortable to sleep on. So paper-based beddings. So now let's move on to goal. So what can actually give a good life? These previous examples are stuff that we can do kind of immediately to improve conditions, but still come short of a good life. So what we're striving for is more naturalistic conditions for animals. What I'm going to describe now is a study that I did for my PhD a few years ago, where I housed rats inside semi-naturalistic cages in the lab. I used one of the most common pet rat cages that had several levels, and the bottom of the cage was filled with burrowing substrate, so the animals could also burrow, since we know rats are burrowing rodents. I also had a standard condition, which was just your conventional standard cage with 2 rats in a tunnel. These rats were ordered from Charles River, and they were randomly assigned to treatment, so standard or semi-naturalistic upon arrival. I want to show you a video just so that you get an idea of what this looked like. So this video was shot at the same time. I was kind of panning between the standard cages versus the enriched cages. This is how different the animals will behave just based on the fact of where they're housed. So the rats on the left side are doing nothing. And unfortunately, many people who work in labs, I've heard them say that this is kind of what rats are, that they're lazy, that they're sedentary, when we know this really absolutely is not the case. Because when they have things to do and they have more space, they do become more active. Okay, so in this study, my rats had been continuously filmed with infrared cameras. And sorry, I don't know what. With infrared cameras, and then I scored 3 behaviors that appeared to be really frequent in these large cages, and yet were not even possible in the standard cages. These behaviors were burrowing, climbing, and upright standing. The reason I'm bringing up upright standing is that in a standard cage, up to recently, at least the standards are slowly changing now, but rats are not even able to stand fully upright. So they cannot get their back straight, they can't stretch upright, they can't extend their legs, as opposed to the picture on the right here. When I'm talking about upright standing, I'm talking about fully stretched back and also the back legs fully extended. So I scored these 3 behaviors when the rats were 3, 8, and 13 months old to look at differences during development. So what we found for burrowing, I'm going to start off with a video just so that you can see what that looked like. I should say that the burrowing substrate there was like a plexiglass that was lining that to hold it in. In this case, we're lucky because the rat was burrowing just behind the plexiglass. So we get to see what that looked like inside the tunnel. And spoiler alert, the rats did burrow a lot. All right, so in terms of results, here on the x-axis, you have the age of the rats, 3, 8, and 13 months old. And on the y-axis, you have the frequency of burrowing per day per rat. What we found is that rats burrowed about 30 times per day throughout at least that first year of life that we looked at. And this fact that they burrowed at a constant rate as they grew up is suggesting that burrowing is a particularly important behavior for rats. And here's why I say this. We know that as different individuals, including humans, get older, we become less active with age. So when we're young, we're super bouncy off the walls, running around, just have so much energy, constantly moving. And then as we get older, we will trade some of those less important behaviors for rest. Whereas things that are quite important, we're going to continue to do at the same rate. So here, the fact that rats did become less active with age, and yet they continue to burrow at the same rate suggests that it is something that they weren't willing to trade, that there was something that they found particularly important and wanting to continue to do. I also wanted to say that they actually did use the burrows every night when the light was on. They would go down there and that's where they slept. We also found evidence that burrowing was something that the rats really enjoyed doing. So it seemed to have a function beyond just having a burrow. It seemed that the actual building of the burrow was something they really enjoyed. And I say that because, as you saw, so there were 5 rats in the cage. Every one of them burrowed about 30 times per day. So the tunnels were always still there. They didn't collapse. So even though they had tunnels, they would still go and like make a new one. So destroy this one, make a new one. And their demeanor while they were burrowing was suggestive that they were excited. So they were doing a lot of bounding and kind of this twirling behavior that we know indicates excitement in rats. And then moving on to climbing. Again, I'm going to start by showing you a video. What we found is that rats will be climbing sometimes to get from one place to the cage, in the cage to the other. Sometimes it seemed to be just for the sake of it, like to explore. All right, so here we're going to have the same type of graph where you have age on the x-axis here and then the frequency per rat per day. So in contrast to burrowing, what we're seeing here is that climbing did decrease substantially as the rats got older. When the rats were really young, so when they were 3 months old, they climbed about almost 80 times per day, which is a lot. And then it seemed that by the time they were 13 months old, they kind of didn't seem to be able to hold on as much. So it seemed like it may have decreased because of physical ability. They seemed to not be able to grasp the wires as well. The important thing to note, though, is that in a laboratory, in research, rats are almost never kept until they're even 8 or 13 months old. So the rats that we do keep that are 3, 4, 5 months old, in these animals, climbing is a behavior that seems to be quite frequent. And they should probably be given the opportunity to perform it. Okay, final behavior that I looked at was upright standing. And there's going to be 2 types that I'm going to walk you through and show you examples of. So the first type that we saw that was by far the most common was what we called exploratory standing. So what you see in this rat here, she's sniffing, her head is moving. So she seems to be standing up for the sake of exploration. She's checking out what's happening in the upper sides of the cage. And here's the other type where we call this a stretch. So what you saw, there's a back arch, there's a stretched paw and a yawn. And you're going to see this again here, stretch paw and a yawn. So the stretching happened about 10% of all the upright standing, and that exploratory was about 90%. Here's the same graph again. So what we saw is that upright standing was by far the most common behavior that we saw. So when the young rats, 3 months old, they stood upright about 175 times per day, which equals about every 4 minutes. And even when they were older, they were still standing at about 75 times per day, which was about every 10 minutes. So super frequent. one of the reasons we think that this standing upright may have decreased with age is that exploration is one of those behaviors that is known to decrease with age. And since we know that they often stood upright to explore, this is the likely explanation. All right, so seeing this and seeing that rats in a standard cage cannot stand upright, which means they cannot stretch upright, it led me to hypothesize that rats that are standard housed may be compensating for this inability to stretch upright by doing a lot more lateral stretches. So these kind of horizontal stretches that you see here. So in this study, I wanted to compare the frequency of lateral stretching between the two systems when rats were 13 months old. So what we found here on this axis, you have the housing conditions, so semi-naturalistic rats versus standard rats. And on the y-axis, you have the frequency per rat of lateral stretching. So indeed, the hypothesis was supported. We found that standard house rats were stretching laterally way more, so about 8 times as much. That seemed to be excessive, like that seemed to be way more compensating than is warranted. And so I went back to the data and then compared the frequency of all stretching in the semi-naturalistic cages and standard cages. So as you recall, standard cages, there's no upright stretching. That's not possible. All they do is lateral. Semi-naturalistic cage, the pink bar is the lateral stretching and the blue bar is the upright stretching. So even when you look at all of the stretching happening in semi-naturalistic cages, that's still about 1/3 of the amount of the standard cage. So what this means is that this inability to stretch upright for standard rats doesn't seem to alone account for the high rates of stretching that we're seeing, and that something else is going on. If you then look at the literature on stretching and why we do it, it's said to be a corrective response to stiffness that is caused by positional stress or immobility. So the implication here is that low mobility in standard cages may be leading to stiffness and positional stress, which rats attempt to alleviate through frequent stretching. So not just the inability to stretch and stand upright, but also the fact that they can't really move, burrow, climb, or do anything else. So here's another example of caging that was done in the UK. So these guys used ferret cages, and they would use 2 systems that were connected by a tunnel. They outfitted these cages with a bunch of rat-friendly things, such as a lot of nest boxes, nesting materials, hiding tubes, etc. What they found is, first of all, they housed about 20 to 30 rats per double unit. And they found that these rats that were housed in these systems were a lot calmer, they're easier to handle, and they didn't startle as easily. So normally when you enter a rat room and if there's a clang, they will all kind of freeze. In this case, they would not do that anymore. These rats also started displaying their species-specific hopping gait that I told you about earlier, this excited gait. They were climbing, jumping, nesting, and they were engaging in this cooperative hoarding, which is also natural behavior, and extensive foraging. Here's an example of improved housing for mice. So these are large bins that are about 120 centimeters by, so about 1 meter by 1 meter. Just for reference, inside these bins, you have 2 standard shoebox cages. This is where the mice could go in and access food and water because there's a little hole drilled into the side of the cage. The cage was outfitted with a bunch of different items that were rotated, and its conformation was changed weekly as they cleaned the cage. What they did is they would place 10 to 20 mice per bin, and they found that mice who lived in these bins compared to standard housed mice, these mice had less fat, they had stronger immune systems, and lower corticosteroid levels, which means they were less stressed. These guys were actually cancer researchers, and what they found is that when they injected cancer cells into these mice, they found that these mice living in these large bins had a longer latency to develop tumors, and they also developed smaller tumors. Their hypothesis was, and they found some evidence of that, is that these dynamic social interactions that are possible in these setups that have more animals, all the novel objects and the physical activity, led to a mild and beneficial activation of the HPA axis which then led to better buffering against larger negative stressors. So when they were challenged with cancer, they were better able to cope with that. All right, so I walked through a few examples of what ideally we should be doing for these lab rodents. The reality is it's not going to happen from like tomorrow. It was very expensive and labor intensive to retrofit an entire lab. I mean, this is where we should be going. But in the meantime, what can we do tomorrow is something called playpens. So the idea behind here is that rats live in standard cages, but they do have regular access to a more specific, a species-specific area. So the first time I heard about this playpen idea for rodents was from a scientist at AstraZeneca named Kate Shenton. So she worked at AstraZeneca and found that this facility, they had a bunch of cages for rabbits that were sitting empty. They didn't have any rabbits at the time. And she decided to retrofit them and fill these cages with a bunch of rat-friendly items and see what happened. So video is going to be playing. What she did is, so these were rats that were on telemetry studies, and on their off days, she would place a few groups inside this retrofitted rabbit cage. And so these rats are pair housed, but they would go into this playpen in groups of 8 to 12. She would do this 3 times per week and started off with about a half an hour a day. And then eventually found that it was great. There was no problems and would leave the rats in there for several hours a day. She also observed that the rats were calmer and more confident and more interactive with her when they were handled. What I want to draw your attention to in this video is that everything in this playpen is stuff that is already at the facility. So it costs nothing to do this. Just using empty cages, extra nesting material, paper towel rolls that are empty glove boxes, etc. And here's another example of a mouse playpen. Whenever I talked about rat playpens to people, I'd always get the question, what about mice? Do mice like playpens too? So myself and a PhD student at UBC, Anna Ratuski, did a study looking at mouse playpens. So what we used is, to make the playpen were 2 rat cages that were connected by tunnel. And then we'd bring the mouse standard home cage and connected with a tunnel, and the mice had the choice to enter the playpen willingly. So this is what it looked like. One side of the playpen contained a bunch of climbable structures and had a running wheel, so just things to play with, climb and run through. And then the other side of the playpen had burrowing substrate, so the animals could burrow. And we used 2 different substrates. One of them was soil and the other one was coconut fiber. Both of these materials were autoclaved when we brought them into the facility, and so they were super clean, nothing grew in it, and it was pretty safe. So in this study, what we did, we wanted to see whether mice showed evidence that they found the playpens rewarding, and this was something that they wanted to do. So we used anticipatory behavior, which is a test of how excited they get, to measure whether access to playpen is rewarding. So the way anticipatory behavior works is that you train the animals to associate a sound cue with transfer to the treatment cage. And then you actually wait about a minute between when the cue is delivered and the transfer to the treatment. And during this 1 minute is when you look at anticipatory behavior. I'm going to draw your attention to, for those who have cats and dogs, to think about anticipatory behavior is, for example, if you have a dog and always before the walk, you kind of grab the leash and that signals to your dog, oh, that means we're going for a walk. And at that point, the dog will get up and will start stretching and kind of doing circles around you and just getting really antsy and moving a lot. So that period between the signal of you grabbed your leash and actually going outside, you have this kind of period of increased activity. And that is anticipatory behavior. And we can measure that in animals by looking at the frequency of different behavioral elements that they perform. So here's a video of what that looked like in the mice. So we had our control mice that were placed, just want to draw attention, that finger, that is the sound cue, it made a sound. So the control mice would be placed on the table, they would wait a minute, and then they'd go back on the cage rack. The other mice would wait a minute and then go into the playpen. So you can see kind of right away the difference in behavior. So these mice that were going to go to the playpen, when they heard that signal, they started moving a lot and going about and kind of getting excited, whereas the control mice where the cue didn't really mean anything. They were just going to get back to the cage rack, didn't really increase their behavior. So here are the results. So what you're looking at here, we had 3 different strains of mice in each cage. You have BALB, C57s, and DBAs. That's what we're looking here at on the x-axis. And the y-axis shows you how many behaviors per minute each mouse did. And this is a change from baseline. So what we saw is that as the animals learned to associate the cue with playpen or the cue with nothing. So in the control mice, their change from baseline didn't really change. There was no difference. Whereas in the playpen mice, they did increase their behavior substantially. So that shows us that, yes, going into the playpen is something they find rewarding and they're excited about. So I want to bring a word of caution here because, again, when we talk about playpens, it's a really cool idea, but it can be labor intensive. And so I've talked to facilities that will have, for example, 60,000 cages in their facility. And so they can't logically or easily transfer mice, like keep rotating them like for half an hour or an hour each day. It's just too much labor. And so what people started doing is putting these animals in these playpens for a few days at a time or a week at a time. I want to caution you against that because I think if this stops being something that is kind of happens every day or every few days for a period of time, it goes from being something temporary to being permanent housing for a while, and that then this is taken away. That's probably problematic. There are research studies showing that removing enrichment from animals is actually a new model of inducing helplessness, and HPA axis dysregulation leads to overeating and other issues. So kind of we need to think about this carefully. And then this may be probably suited for smaller facilities that can rotate these animals daily and not let them live in there and then take it away for a few weeks at a time. All right, and now the sky is the limit. I'm going to move into some more naturalistic kind of outdoor or whole room housing, which I think is where we should be going if we're really going to be considering a good life for animals. So here's an example from Timothy Jones, who worked in the UK at the Defense Science and Technology Lab. These guys set up a whole rat room, and he told me that they also had some brewing substrate. It wasn't there at the beginning, but as soon as they added it, that is kind of all that the rats wanted to do. And again, they just spent all their time brewing and jumping in and out. It seemed to be something really exciting. In that room, they had a litter box in the corner, and they said that the rats continuously used that. And so they would basically have to change that every once in a while, but not really have to clean the rest of the room. And here's an example from Dr. Koenig from the University of Zurich. She, back in 2002, I believe, captured 12 house mice and placed them in this former barn that she outfitted with nest boxes, straw, nesting material, and commercial rodent diet and water. The thing about this barn is that it was absolutely open to emigration and immigration because there were little holes in the walls and by the roof, which means that the mice were free to come and go, but the predators could not come in. She found that even though she started with this group of 12 mice, there are now about 200 to 300 mice that live there voluntarily at any one time. She will implant these mice with RFID tags in order to monitor their coming and going from the nest box. And she uses this setup for many years now to study social behavior, reproductive behavioral, maternal, and sickness behavior in mice. And just a note that people often ask, but how do you catch the animals to implant them or whatever you need to do? In her case, when she would enter the barn, the mice would naturally retreat into their boxes. And so at that point, she would place just a little jar at the entrance of the box, once she left, they would naturally come out into the jar, and that's how she would catch them. So this is a cool example, but obviously the ability to leave a study site is not always advised. So if you're using genetically modified animals, you can't allow these animals to reproduce with the natural population. Also, if you have animals who are physically or physiologically compromised, you don't want to be letting them out into the world where they can't really fend for themselves or defend themselves properly. So here is another example. This one is from Dr. Graham at Princeton University. She uses outdoor enclosures. So in her setup, it's a circular enclosure with wedge-shaped pens. This one is close to immigration through the use of tall and deep walls, and also some predator deterrent from birds of prey. So in this setup, the mice can burrow in the soil, they can eat the vegetation. They are also given a straw-filled shed, water, and rodent chow. And this researcher is an immunologist, and she found that these dirty mice actually make much better models for immunology than traditional lab mice. And so, for example, what she found is after using these, studying immunology in standard house mice, she found that housing them this way, she found some new environmental factors that never expected to be crucial drivers of the immune system, and that she never would have known had she not housed them in these more naturalistic systems. Here's a final example. Again, kind of looking at these free-range animals, but indoors, because sometimes you do need to control or have more control over temperature or rain or things like that. So this is an example of Dr. Potts from the University of Utah. He has been using this setup since the 1980s. He calls this a fully enclosed barn. He has about 30 mice that live in this setup. And basically what it is that this setup is divided into two different territories. There's the high quality and the low quality. The high quality territories have closed nest boxes, which are preferred because they're dark and safe. And the low quality have open nest boxes. So mice that live in this barn will have to compete for territories. And those who are more successful will gain more mates and also produce more offspring. And he uses this setup for many different types of studies, but among them is drug safety testing. And what he's found is that testing drug safety using animals that are housed this way is much more sensitive than testing standard house mice. So what he's done several times now, and I'll give you a specific example in a second, is take a drug that was tested using standard housed mice and standard housed either dogs or pigs, found to be safe. They didn't find really any effect, went into the human population, and then had to be pulled from the market because of unacceptable side effects. So you would take these drugs, and here's an example of one of them, which is servastatin, approved for human use based on standard data, then pulled from the market. He found that mice who were given this drug and then released into this setup, they had 41% fewer offspring. They occupied 63% fewer territories and had 10% lower body mass. So what I failed to say, so half of these mice were given the drug, the other half were not given the drug. And he found that the mice who were given the drug were really at a disadvantage. And had we tested this drug safety using animals in a more naturalistic setting, we would have picked up the more subtle differences and not release this drug to the human population. All right, so that was kind of the things that we can do for the physical environment. Now I'm going to move on to interactions with humans. Immediately, what can we do? Just handling and restraint. So this is something we'll do, maybe not daily, but in every research study, we do have to handle the animals, pick them up, and do some procedures. And the way we handle them really has a profound impact on their welfare. And we should be using methods that will give the animals more control, so to increase this agency over that interaction. So here's an example with the rats to record blood pressure. So in the standard way, these animals are placed into some kind of restrainer device, and then the blood pressure is taken. In this new method, the researchers just placed the rats on a table and used a bed sheet or large towel that they cover the animals with. And what they found is that animals whose blood pressure was measured using this less restrained method using a sheet had lower arterial blood pressure, they struggled less, they defecated less, they had fewer audible vocalizations, and they did note that the time to obtain the blood pressure was similar between the two methods. In this other example, here's an example of IP injections. Typically, what is done is kind of methods A, B, and C here on the left, where you encircle the rat fully with your hand, or you can kind of scruff as well, either with the legs resting on your abdomen or the rat hanging. In their modified method, you only half encircle the rat. So you only hold on to kind of the back and you rest the bottom feet on your abdomen. And what they found is if you use this last method, this much less restrictive restraint method, is that these rats had lower plasma corticosterone, they struggled less, they defecated less, fewer audible vocalizations, and they also had a more positive emotional state after the injection. So really simple things that we can do immediately when using animals. This is an example of mice. I think most of you know about this. It's super common. It's been known for years, and yet it's still not widely applied. But basically, common way of lifting a mouse is by the tail. We know that this is really bad for mice. It is very stressful. It is probably because in the wild, in mice, when they are preyed upon by birds of prey, they are caught by their tail. So this is kind of this typical prey interaction when you handle them this way. What they prefer much more is to be handled either through a tube or cupped hands. So there's dozens of studies on this now, but basically mice who were handled by the tail versus the other two methods have lower voluntary interaction with the handler. They do more urination, defecation during handling, which signifies that they're stressed. They have higher anxiety and depression in behavioral tests, and they also have higher plasma corticosterone levels. So really, we really should stop doing this. There's also a lot of studies showing that this does not take much time, maybe during the first or second time you're using this new method, but after that, it's actually just as effective. So now moving on to intermediate, maybe a little longer term, but still things that are fairly easy to implement. We need to be socializing rats and mice because they are naturally afraid of humans, and yet we're daily presence in their lives. Socialization is not just habituation. It involves building a trusting relationship so that both parties can enjoy the interaction. Like I said, goes beyond just routine handling for cage changing or weighing. It involves more of a friendly interaction, such as gentle petting and giving treats. So there's different protocols out there. I'm just going to show you three examples. So in this one study, they had rats that were softly touched over the entire body. They were hand-fed treats. They were talked to in a friendly and soothing manner. They would do this 10 minutes per day, twice a day for 2 weeks. And another protocol, these guys would place a rat on a table or in their lap, and they were just gently stroking them on the back and the neck. They would do this for 5 minutes a day, 5 times per week for 6 weeks. And with an example with mice, they just placed the mouse in the palm of the hand and then gently stroked the flanks and the head for 90 seconds every second day for 13 days. In all of these examples, compared to animals that were only handled routinely for cage changes and weighing, rats and mice that were gentled or been subjected to this socialization protocol had less vocalization, less freezing, lower anxiety in behavioral tests, etc. So again, something that is really worth doing if you don't want to stress out your animals on a daily basis, and also to get better and more reliable data. I also have to mention rat tickling, which is a specific form of interaction with rats. It's meant to use your hand in a way to mimic the rough and tumble social play that rats would do together. What studies have found is that rats who are tickled, once you've established a relationship with them and you have a good and trusting relationship with them. And when you tickle them, they will laugh. So they will produce these vocalizations in the 50 kilohertz range that indicates that they're excited and happy. Studies have also shown that rats who are tickled will seek out human hands more than rats that haven't been tickled. And they also have reduced responses to various stressors. So now let's talk about the goal. So where are we actually going with this human-animal interaction in order to have a good life? So the ultimate goal is to train your animals to voluntarily cooperate with medical and experimental procedures in order to give animals maximum control and agency over what happens to them. So here on this photo, for example, is a rat who was trained to sit on a scale. So instead of, restraining the rat, and it's always kind of takes a while and they're struggling and they don't want to be there, you train them to sit and get a treat. It's more efficient and it's much more enjoyable for the animal. I don't have photos with rodents of this, but again, just an example with monkeys is typically you will grab the monkey, two people will restrain them in order to give an injection. It's something that's really stressful. Versus what we should be doing is, again, using positive reinforcement training so that the animals volunteer their limb in exchange for a treat. This isn't super common with rats and mice, but there is this one institute in Sweden called RISE, where they are doing this for all of the rodents that come into research. So they're a toxicology facility. And a few years ago, they decided that they wanted all the rodents to be calm participants in the procedures that they were doing at their facility. They wrote a really nice article about their procedure in the AWI Quarterly for anybody who wants to read about that. But here are some examples of what they do. So every single rat and mouse that comes into the facility, regardless of how long they're going to stay there, whether it's a few days, few weeks, or a few months, will go through about 5 training sessions before they are used in an experiment. And each session is only about 1 to 2 minutes. So really not that much time that is put into this. And what these training sessions consist of is basically grabbing the animals and gently holding them, touching them, and getting them used to being touched in a way that they will be touched in the procedure. So on the left-hand side picture, for example, this rat will be subjected to either blood draws from the tail or something like that with injections and blood and tail handling. And so during those interactions, they will make sure to touch the tail a lot so that when you come in and you are doing this blood draw, the rat doesn't flinch and overreact. In this other example, they also do a lot of inhalation studies because they are a toxicology facility. So instead of grabbing your mouse and forcing them into this restraint that they have to stay in for a few hours to breathe something, during these training sessions, they will give these animals free access to the actual device. They place treats near where the nose has to go. So the mice and rats learn to voluntarily enter the restraint tubes. They associate it with something positive. So here's a nice quote that they wrote in that article that I told you about. So they said that handling and training rodents before a study begins can seem time consuming, but the truth is that it saves time. When we start our studies, we never have problems with dosing and sampling procedures due to stressed and struggling animals, and we minimize stress-related mistakes. So in conclusion, from what we've covered today, so my and Dan Weary's vision of a good life is something that will include both excellent living conditions and also the ability to choose whether or not to participate in any procedures. Now, I absolutely realize that animals can't give informed consent. So while you can train them to, give their limb and to participate willingly into like getting an injection, for example, you can't expect them to know or to volunteer for that injection to then cause them cancer or Parkinson-like symptoms or something like that. People who really want to give animals a good life could, just take a stance that they won't do this type of research. some of that work then could be shifting towards studying pets that have naturally occurring diseases. So instead of taking your healthy lab animal, inducing obesity or inducing these diseases, you can recruit pets and study that in them if possible. We absolutely, again, realize that the application of these options of providing animals with a good life will require a lot of creative thinking. I think that's the number one requirement, a lot of careful planning. So you really have to plan things out before you start your study and not as you go. And obviously will take substantial monetary and time investment. But we also argue that these changes will provide a range of benefits, including animals who are more pleasant and interesting to work with, better staff morale, and also data that are more relevant to the questions at hand, which is the reason why we're using them in the first place. And with that, I thank you. And I welcome any questions.